part of the moment 3 dimension, which is moment of a force about n axis. Okay, now the thing is, it is for n axis. Before this, the previous video, we have discussed about moment of a force about a point. Okay, moment of a force about a point in 3D. Now it is about n axis. Okay, so I will use the same example for the previous one. Okay, so the previous one we have shown what is the moment of a point, which is about point A from this force F. Okay, we have one force. Calculate the moment about point A. Now we want to calculate a moment about axis AB because of this force 3000 Newton. So the moment about n axis, let's say we use this one, moment of AB, okay, equal to lambda AB, moment of A, or lambda AB, moment of B. Okay, meaning that here we have moment of AB. Okay, moment of this force about axis AB. We can choose either two. Okay, the first one we take lambda AB, moment of point A. Okay, we have from A to B, or you can take lambda AB and moment about point B. Okay, which one you choose, you will get the same answer. So you have the choice. Okay, but since in this example, we have already calculated the moment about point A, so I will use this one, moment about point A. If you still not have the answer for point A, you can choose the point B. Doesn't matter, you will have the same answer. Okay, so what is lambda AB now? So moment AB is the moment of a force about axis AB, MA. So we go to lambda. Okay, lambda, and what else we have? Okay, so we have lambda AB. Lambda AB is the vector unit from AB. Okay, vector unit from A to B. Okay, vector unit from A to B. Vector unit from A to B. So we have moment about point A, or moment from point B, dot the lambda, which is vector unit from A to B. So what is the vector unit? Okay, we have seen that the first one. This one we have what we used before. MA is RA, from A to any point of here. Let's say we use AC cross F, R cross F. So this is the moment. Okay, so meaning that if you want to calculate the moment about an axis, you have first to know how to calculate the moment about a point, because you will apply here. Okay, so moment of this one, lambda AB, MA. So MA equal to RAC, or any A to something. We have discussed from the previous video. Okay, so you can choose one. The easiest one here I can see AC. Okay, and then cross F. Okay, now we will do the dot product from lambda AB to MA. Okay, so the moment about an axis, this one, you see this one, it is a cross product. Okay, so moment about an axis is a cross product, and it is, we call it cross product scalar quantity. Okay, it is a cross product, and then it is a scalar quantity. Okay, so meaning that the final answer is only a number. Okay, they will not have any direction. Okay, if you go back to moment about a point, the final answer is in terms of I, J, K. So we still have the magnitude and the direction. But for this one, we only have the magnitude. Okay, only the scalar quantity. Okay, so this is a cross product. Sorry. It is a dot product. Okay, it's a dot product. The cross product we do for lambda for moment of a point, it is a cross product. Now it is a dot product for moment about an axis. Okay, so what we need to do to know is previously we have seen this one R cross F. If we have a cross product P cross PQ, we have done is P cross Q equal to PQ sin theta. But for dot product, P dot Q is equal to PQ cos theta. Okay, so P dot Q is a PQ cos theta. Okay, and we know that cos 0 equal to 1, cos 90 degree equal to 0. Okay, so cos 90 degree equal to 0, cos 0 equal to 1. Okay, so because of that, later on you will see that I dot I equal to I dot j equal to I dot k equal to, and so on. So we have ij, ik, and then we go to what else? J dot I equal to j dot j equal to j dot k equal to k dot I equal to k dot j equal to, and then k dot k equal to. Okay, so ij, ik, and so on, we know that the angle between is 90 degrees. So cos 90 degree will be 0. So everything here will be 0, 0, 0, 0, 0, 0. Only the I dot I, j dot j, and k dot k, which is equal to 1. Okay, we will do the same thing as in the cross product. We will do one by one. But because of all others which is equal to 0, our job will be simplified by this one. We only find the thing which is same I dot I, j dot j, and k dot k. The rest of it we will ignore. So our calculation will be simplified by that one. Okay, so now we have what? Moment of AB, the equation lambda dot MA. So MA, we know what is MA from previous video. You know how to calculate the MA. And we know that this dot product is cos theta. So cos 1 equal to 0, cos 90, cos 0 equal to 1. Okay, cos 90 equal to 0. So from here we can eliminate everything, leaving us only I dot I, j dot j, and k dot k. So now our problem is, what is the vector unit here? Lambda. Okay, lambda is the vector unit. So what is the vector unit in this case? Vector, where is my vector unit? Vector lambda AB is a unit vector from A to B. So unit vector from A to B. So maybe I will erase everything else. So unit vector. Okay, so again we have lambda. This is unit vector. Okay, so unit vector, if you look at the force in 3 dimension, we have resolved the force in 3 dimension. When we resolve force into 3 dimension, we have 3 method, which is first angle method, second angle method, or coordinate method. So from first angle method, we have F equal to F cos theta I plus F cos theta yj plus F theta x, F cos theta z k. Okay, and then we go to second angle method. F equal to, let's say we have F cos and sine. Let's say it is depend on the figure. So I'm just writing the possibility. So we can have sine theta cos alpha I plus F, this is sine, So cos theta j, okay, plus f sin theta sin alpha I. Okay, so maybe that one, f sin cos y. Okay, so we have this one, and in terms of coordinate method, f equal to f dx divided by di plus f dy divided by dj plus f dz divided by dk. Okay, so from here, okay, this thing here, cos theta xi sin this one and dx divided by this one. Okay, this one, 2, and here, this is actually lambda I. Okay, it is lambda I or lambda xi. And then we have any other color, blue, cos theta y, this one, cos theta, dy, this one, okay, all these three, this is lambda yj, and the last one here we have cos theta z, this part and this part. Okay, so this one, this is lambda z k. Okay, so actually this is the lambda. Okay, so this is the lambda, the unit vector. So we have the lambda. Okay, so previously we have, okay, position vector. Now we have the lambda. Okay, so we have the equation, and then we know what is the each of it. So moment of n axis, moment about n axis AB from the force. So we have lambda AB, moment A or moment B, so depend. So from this one, lambda AB, you know how to calculate this one, RAC cross F. You can choose A from arc, from AC, AD, and so on. Okay, cross S, F, this one will leave us with vector unit, which is moment in terms of moment xi, moment yj, moment zk. But when we do the dot product here, the final result will be the scalar only in terms of magnitude only. There is no direction. Okay, so we look at the example, which is I will use this one. I will use this example as what we have from previous video. So I will leave this one. Okay, so we want to use more space, so I will have. So what we will do is I will do this moment of this one, moment of AB, which is I will choose one of it. Either we do lambda AB MA or lambda AB AB. But since we have calculated from previous example using lambda moment about point A, so I will stick by this one. So we already have the answer for that one. So lambda AB dot MA. Okay, lambda AB dot MA. Okay, so lambda AB, what is lambda AB in this case? Okay, so if I want to elaborate a little bit more, lambda AB dot MA is RAC cross F. Okay, RAC cross F, RAD, and so on cross F. So from previous calculation, what we'll have is the equal to, this the lambda dot. Here we have calculated actually this one from previous video. Go back to a previous video. You can see that we already have 800 Newton meter I minus 480 Newton meter J, and then plus 800 Newton meter Okay, so this is what we have from previous chapter. The MA, moment about point A. Now we want to find the lambda AB. Okay, so lambda AB in this case, it is, so we look at this one, unit vector. Okay, lambda AB is a unit vector, so from this one you can see that we can use the coordinate method. So we have to put the value. Okay, still we have this one, 1.2, 2.4 and 2.4. Okay, so this one, we know that we have coordinate method, so we do dx equal to dy equal to dz equal to, so dx in this case from A to B, so dx moving this direction, so positive x, 2.4, dy going downward, so negative 2.4, dz from there moving positive z, so positive 1.2. From here we can calculate the d. So we have calculated the d. What is the d? Is 3.6. Okay, so the lambda AB is actually 2.4 divided by 3.6 I minus 2.4 divided by 3.6 J plus 1.2 divided 3.6 K. Okay, so that is the lambda AB. Okay, so same as cross product, we will do it one by one. So this one will go here, and then we go there, and then here, and we continue and then we use this one, 1, 1, 1. But since we know that only I.I, J.J and K.K will be 1, the rest of it will be 0, so we don't have to bother about the others, just go directly find the I, J, and KK. So what we have is 2.4 divided 3.6 I, 680, 0, 0. Okay, so I dot I. And then this one is 0, this one is 0. So we go to this one. Plus minus 2.4, 3.6. Minus 480 J dot J, and then the rest is 0. We go to K plus 1.2 divided 3.6, 800 K dot K. And then because this will be 1, 1 and 1, so that we already eliminate the direction I, J, K, because now it become 1, only 1, so we leave only the magnitude. Okay, so you go on calculate this one. What you will have is, lastly, this is the answer 5120. Okay, because this is time 1, there's no more IJK, only the scalar unit, and then it is Newton meter because it is the moment. Okay, so there is the answer for that one, Newton meter. Okay, so again, moment about an axis, you have to know first how to calculate moment about a point, because it will involve in the calculation. So moment about an axis is lambda axis itself, so the vector unit lambda AB, and you can choose between the 2 points of the axis from AB, AC and so on. In this case we have AB, so you can choose from point A or point B. So you know how to calculate the moment about that point first. Okay, let's say we have here moment about point A. So moment about point A is equal to RAC cross F. We have done the calculation, we get this answer. If not, you have to do one by one from the previous video. So go check the previous video. You get this answer. And this RAC is the unit vector from A to C. Unit vector, so you have to look at, in this case, we can use the coordinate method. If it is first angle method, you use cos theta x, cos theta y, cos theta j. If it is second angle method, you do it one by one. Again, maybe cos theta y, sin alpha, and then for I, and then cos theta y for j, and then sin theta y, cos alpha for the Z, okay, for the second angle method. And then you put it here, you do one by one cross product, but we know that everything will be 0 for 90 degree, leave it only the 0 degree, so I, J, J and KK, just find that one, ignore the others, and then you get the answer. Okay, there is for moment about n axis. Okay. Okay, so now, this is about angle between two vectors. In some exercise or question or final exam, you see that the question will ask you to find the angle between two vectors. And so we can use the dot product to calculate the angle between two vectors. Okay, so we can use dot product. This is dot product. Okay. If the question asks you to find the angle between two vectors, you can use the dot product. For example, here we have the first one, P equal to 3i plus 4j minus 2k, Q equal to negative 4i plus 20j plus minus 10k. So we have all in 3 dimension, ijk. So you can use the question asks us to find the angle between P and Q. Okay, angle between these two vectors, P and Q. So what we'll do is, from the equation of dot product, we have P dot Q equal to P Q cos theta. Okay, so this is actually the theta, which is the angle between these two vectors. Okay, so for example, in 2D, maybe this is P, this is Q, so this is the theta. Okay, so P dot Q equal to PQ cos theta. So that is the theta. So we look at this example. What is P dot Q? What is PQ? Okay, so let me rephrase everything. So we want to have the cos theta. So cos theta equal to P dot Q divided by PQ. Okay, so equal. Okay, rearrange everything. We have that as one. What is P dot Q? P dot Q is this one. 3i plus 4j minus 2k dot negative 4i plus 20j minus 10k divided by P dot Q. So actually it is this is a scalar, the scalar unit, because dot product it becomes a scalar. Okay, it is actually the magnitude of it. So what we do is, here P dot Q, PQ is the magnitude of P times the magnitude of Q. So it is actually square root of 3 squared plus 4 squared plus negative 2 squared, okay, times negative 4 squared plus 20 squared plus negative 10 squared, the square root of this thing. Okay, so once you do that, you will have things like this one. Of course, you only will take the this part, which is I dot I, J dot J, and lastly we go to this one. Okay, so 3i, 3 times 4i, and then plus 4 times 20 plus 2 minus 2 and 10. Okay, so equal to here, which is this one with this one, negative 12. 4 and 20 is 80. 10 and 2 plus 20 minus this one, you will have 5.385 times 22.75. Okay, so the cos theta equal to this thing. Okay, so you have the cos theta cos theta equal to, this one equal to, calculate, divided by these two, you have 0.719. So theta equal to cos minus 1. This one, you have theta equal to 44 degree. So theta equal to 44 degree. Okay, so the question if the question wants you to find the angle between the two vector, we can use the dot product, which is P dot Q equal to PQ cos theta, and the angle is this one. You put it one by one. This PQ will become a scalar. Okay, this one is the magnitude of P and magnitude of Q divided by these two. You have the cos theta, cos minus 1, you get the answer for the theta. Okay, so that's all for the moment in 3 dimension, which is the first one. We have looked at moment about a point. Okay, and the second one is a moment about an axis. Okay, later on maybe we go to several examples from question from the books. Okay, to see how to calculate the moment about an axis or about a point. Okay, so see you later in my next video.